Hello students, now we'll be discussing about the cross product of vectors. We have learned about the cross product. There are two types of vector products between two vectors. When both the vectors are along the same direction, or when we take a projection of one vector on the other, in that case we get a scalar dot product. But if we have to take a vector product, so vector products go like, so if one vector is going like this, the other vector is going like this, then the resultant of these two vectors is going to be the perpendicular. So let's learn about the cross product. So cross product is what we are going to discuss in this particular part.
The next topic that we are going to discuss now is the cross product. So as you can see from the figures itself, cross product, which you would have done in vectors as well, so cross product is basically given by something like A cross B. So the result of A cross B gives you the final value, that is the vector C. Now the vector C, which is equal to A cross B, is actually perpendicular to both these vectors, that is the vector A and the vector B. Further, the vector A and the vector B are they can be at an angle, and the maximum value is going to be there when A and B are actually perpendicular to each other. So what you will get using this, so that this basically is the right hand rule that you have. So using this right hand rule, you can find out what is going to be the direction of A cross B. So when you move from A towards B by an angle phi, so you are basically going like this. So when you go like this, in that case the thumb points to you along the direction of A cross B. Similarly, when you come from B towards A, you are going in the reverse direction. That's the reason you have B cross A. So B cross A will have a value which is going in the downward direction. So again in this case, this resultant A cross B is perpendicular to A as well as it is perpendicular to B. A and B may be having an angle phi. For maximum value, phi should be equal to 90 degree, else and for minimum value, phi should be equal to 0. Right? So that is what is the introduction to the cross product. Now if we have to go further, so cross product or vector product as it is commonly known as, of two vectors A and B is a multiplication of vectors, but the result is a vector quantity C. So that's what I mentioned. So with the direction perpendicular to both the vectors A and B, and the magnitude value is going to be equal to AB sine phi, where phi is the angle between the vectors A and B. The orientation, that is from which direction to which direction you are traversing the angle phi, that defines for you about what exactly is going to be the direction of the vector C. That is whether you are coming from A to B or whether you are coming from B to A. That is very, very important. If you want to find out the magnitude, so in that case we will say that C is equal to AB sine phi, where phi is the angle. This is the magnitude of this particular vector. Here A represents the magnitude of the first vector, vector A, and B is the magnitude of the vector B, and phi is the angle between the two vectors. And the direction of the cross product, as I mentioned, is given by the right hand thumb rule. So what are the properties of this cross product, which you would have studied before as well? First of all, cross product is anti-commutative. Anti-commutative means what? As you can see from this, A cross B is directed like this, B cross A is directed like this, right? So that means using vector notation, A cross B should be equals to minus of B cross A. That is what is meant by this being anti-commutative to each other. Okay. Further, parallel vectors have cross product of 0. That's what I mentioned, that if you have two vectors which are making an angle 0 between them, in that case the net resultant of them is going to be 0. Further, the cross product obeys the distributive law, which goes like this. So if you have, let's say, A cross B plus C, in that case this can be written as A cross B plus A cross C. So this is the distributive law that is obeyed by the cross product. Further, the product rule for the derivative of a cross product is going to be given by, and this is the normal product rule that is going to hold good. So you first differentiate one, keep the other one as it is. Similarly, differentiate the other, keep the other one as it is. So this is the product rule for derivative of a cross product. So this is how it goes. Then if you go further, we'll say that C, which is the vector that has been formed by A cross B, so C is going to be equal to AB sine phi. Now this formula is going to be useful when the magnitude of the two vectors A and B and the angle between the two vectors is known to you. Only then you can find out the value of C. If either of these three values are not given, you cannot find out the value of C. Further, If you only know the components, you can write down using the determinant form, which you may be aware of. So using the 3 by 3 matrix, 3 by 3 determinant, you can find out the value of A cross B. So A cross B can be written as AY dz minus AZ dy, and so on and so forth. So using this, you can see that this is the component of the x-axis, this is the component along y-axis, this is the component along z-axis. So Cx represents the component of the vector C along x-axis, Cy along the y-axis, and Cz along the z-axis, where C is nothing but A cross B. So this is how the vector C is related to the vectors A and B, right? So this was the basic notation of the cross product, which we have discussed before as well. Finally, this should be very, very important, because I mentioned that which direction, from which orientation to which orientation you are moving, that is very, very important. So here, if I say I, J and K, these are 3 unit vectors acting along x-axis, y-axis and z-axis respectively. So if you go from I to J, you will get K. If you go from J to K, you will get I. If you go from K to I, you will get J. So that is what is the right hand system. So when you are moving along this particular direction. When you go from the other direction, that is if you take an inverse of it. So when you take an inverse of it, so if you go from I to J, means you are coming basically in the opposite direction sense. So I cross J in this left-handed system is going to be given by minus K. Then J cross K is going to be minus I, and K cross I is going to be equals to minus J. So as you can see, the direction is completely opposite to this one. That's the reason you have the minus signs, because these are all vector components, right? So this basically gives you flavor of the cross product, and based on this we'll further introduce to you about what is the rotational law, the concept of torque. The concept of torque actually helps you to understand and comprehend how any body moves in a rotational space.
So we learned about the cross product. In the case of cross product, what did we see? So if we need to have 2 vectors, the resultant of 2 vectors is going to be perpendicular to both the incoming vectors, and it's going to be perpendicular to the plane containing the initial 2 vectors, right? So the maximum value of the perpendicular vector will get if the initial 2 vectors are also perpendicular to each other. Now let's try to apply that concept to the rotational analog of linear force. The force is going to be the condition which is going to be acting for a body in a linear motion. In the same way, we try to relate that in the case of rotational motion to torque. Why? Because in the case of torque, torque exists when you need to have the object moving in a circular path. So let's try to learn more on this in our next part, that is torque. Stay tuned to it.